Greetings, welcome to Patch a Day number 38. Today I'm going to build a granular delay thing like you have in Waves plugins, and Ableton Live has a nice one. First off, I guess I'm just going to make an object to play through my delay, SF play, like I do in just about all of these Patch a Days. And I'm going to open is that u.aiff and comma loop 1 comma 1 to get it playing. Let's have a zoom in on that. Sometimes I totally lose track when I zoom in, but is that u.aiff loop comma loop 1 comma 1. Alright, I'm going to stick that into a tap in. So a new object, tap in. I'm going to give it a maximum delay time of 10,000. That should be plenty of time, 10 seconds of delay. And I'm not going to connect it directly to a tap out. I'm going to send that tap in connection over a send, because I'm going to use the tap outs in Polytilde. I could use multiple tap ins, but that would just be a waste of RAM since that's what the tap in object uses. I'm going to use the itables, and I'm just going to do a kind of a central metronome here that's going to trigger off all of the grains. I do actually prefer to do the granular stuff inside, so the timing is done within the Polytilde, but this time I'll make it more like a lot of those a lot of granular synthesis examples you'll see out there where it's all driven from the front end. Makes the timing a little bit more dicey, but it works. So we'll just do a random timing on this metronome with the random 10 millisecond randomness and some minimum time of 2 milliseconds between grains. So that'll be the intergrain time, I guess. So yeah, you take the bang out of the metronome, go through the random and the +2 and into the left side to set the time for the next bang on the metro. Then a toggle to turn my metronome on and off. This is going to bang a bunch of itables, and so I'll make a new itable here. I'm just going to type it into an object because I can't find things on the palette. Not really very smart like that. I'm going to label each one of these so I know what they're for. This one's going to be for delay times, and we're going to have five of these tables. One for delay time, one for amplitudes, one for durations. I'm just selecting those and Alt or Option dragging them to duplicate them. Pan, and then the last one for pitch. Okay, so just to make sure the timing stays straight, I'm actually going to trigger these with a bang. Well, use a trigger with a bang on it. So I'm going to trigger T for trigger and 5 bangs. That's just so that I know the order. It's not so vital, the order, except for the last 3. So I'm going to bang my pitch table, bang my pan table, bang my durations table, my amplitude table, and then last of all, bang my delay time table. This delay time, since the delay time is 10,000 milliseconds maximum in there, I'll bring up the inspector, select it, and hit Command I to bring up the inspector, or Control I if you're on a Windows machine. And I'm going to make the table size 10,000 because that's what my maximum delay time is. 0 to 999 on that, that's fine. Now to do the voice allocation for the polyphonic voice allocation for the Polytilde, I'm actually going to use an object called poly, but first I'm going to use make note just as a way of determining the note offs by sticking the durations into the right side of the make note. I'm going to use my amplitudes as the velocity for the make note, and last of all the delay time for the pitch of the make note. This is kind of pseudo MIDI, so we're not really using MIDI, we're just using it for the voice allocation. Poly without the tilde, and a number of voices, 16, because I'm going to have 16 voices in my poly tilde. The only reason really for using this is this right hand outlet here gives us a voice number in a sort of voice allocation. One thing we're going to do is we're not interested in sending any note offs, so I'm going to just gate this voice number based on the velocity. So 0 velocities will close that gate. Okay, then I'm going to want to pack all these values together before sending them into the poly tilde. So I'm going to use a pack, and there's now 6 things. There's these 5 tables, and the 6th thing is the voice number. So 1, 2, 3, 4, 5, 6 items in the pack. And there's my voice number. I'm going to take the pitch, which is actually our delay time. I'm going to take the velocity, which is actually our amplitude, and the duration. Whoops. I'm going to take the duration, then the pan, then the pitch. Okay. And I'm going to send this to go through a message here. So M for message, where the first item in the list has the target message. So target $1, and then a comma with the rest of the list: $2, $3, $4, $5, and $6, and $6. All right. That should be ready for the voice allocation in the poly tilde. Now we just need to build the poly tilde. So, well, we can save this first. Oh, doesn't really matter. Let's make a new patcher for our poly tilde. And in the patcher here, we're going to make an in for the stuff that we just put together in a list. And we're going to unpack that list. Usually in these kinds of patches, I like to make a comment as to what these items are going to be, so I can remember. Delay time, amplitude. Hey, slow down. Amplitude. I still got that wrong. Does it matter? Amplitude, duration, pan, and pitch. Okay, so we know we're going to unpack 5 values. Unpack 1, 2, 3, 4, 5. Good. I suppose the first thing we could build here or make here is our tap out object. So here's the tap out, and again, to link it up to this tap in on the front page here, on the parent patcher, we'll make this R del to connect this tap out to that tap in. So it's reading the delay line from there. Okay, we could build some of the stuff that's easy to build in here first. For example, pan. I'm going to use the pan2 object, which is not an object but an abstraction. If I double click it, you can see what it's made of. We're going to want to have no fade time, so I might load mess with a 0. I'm not sure whose load mess is going to get there first, but so load mess here for a 0 to be the excuse me, to be the fade time, so that goes in the right inlet. And then this pan value here can just go straight into where it says on the second from the right, where it says 0 equals left, 127 equals right. It's going to work out perfectly for this. All right, I'm going to make a couple outlets here because alt tilde 1, because we're going out left and right channels here, and then alt tilde 2 on the other side. So that's all gravy. And then I suppose the next thing we could work out is the amplitude. We're going to want to, I'm going to create some kind of window. This time I'm going to use a really simple window where I'm going to just take this duration value and divide it by 2. And we're going to go up to the amplitude over half the duration and down to 0 over half the duration. So a new object here, divide by 2 with a floating point, just to be pedantic about it. Take the duration and divide it by 2. For the amplitude itself, we're probably going to want to scale that because 127 is awful loud. Scale it to a 0 float and then 0.5 because we don't really need full 1 amplitudes on these. Granular stuff gets pretty loud. Then some kind of logarithmic scaling value. I put 1.03 in there. You can play around with that number to see what works best, just to create, instead of linear amplitudes, create something that's kind of like volume. Alright, we're going to pack these values together here, the amplitude, these are both floats, and the half the duration of the grain, and we're going to make a message for our line that we're going to drive the amplitude with. Message, we're going to go to $1, which is the amplitude over half the duration, which is $2, and then we're going back down to 0 over $2, which is the half the duration value again. Okay. Now we'll put that into a line tilde, where we're going to use that line tilde to drive the amplitude of this. So we'll use a multiply, new object, multiply tilde, line going in there, and the tap out going in there. And this is going to go into our pan signal in there. Okay, so the next thing we could tackle, which is probably the not so easy thing, is the pitch side of this. The best thing, well, the thing I'm going to do anyway, is to go to applications. I'm going to steal something that might answer at least half the question from the examples in Max. So we go to Max 5, examples, effects, and I've been here in these patch-a-days before, transposer, lib, and the transposer max pat. And you'll see, well, the transposer uses phasers to drive the delay time, the change in delay times. We're not going to use that phaser, but we're going to use some of this maths here. So let's select everything from the clip and the absolute and through to the multiply down there, and copy that and close that up, and we'll just paste that into our patch. Some of this stuff, well, actually this here, where since we're not using the phasers, setting phase to 0 means absolutely nothing. And just to make my maths work, I'm going to use just a fixed window size of 1,000. Lo and behold, the number 1,000 is useful in many ways because it's a second, and it just makes my maths work. And if we just put in an integer box here, this is just for a demonstration, so you don't necessarily need to follow along on this. If I take this and see what we're getting out of here in particular, we can put a float on there, it doesn't matter, just probably an int. We're going to start off at like 60, which is at pitch for this, I thought. Oh no, that's right, 0 is at normal pitch, so that produces a 60. And this is for working in cents, so 1200 would be an octave up, and so that's a 72. You can see these are MIDI kind of values, 60 being a middle C, 1200 an octave up is 72, the octave above middle C, and then minus 1200 is going to give us the octave below, so it's 48. So just to bypass all this stuff here, we can actually just scale our 0 to 127 to 48 to 72. So let's just do that. Let's just cut this stuff. Or actually, before I cut that, let's just see if there's some kind of logic behind this, or if I can explain it. That's probably more to the point. So we got our fixed window here of 1,000 milliseconds, and an octave down, or negative 1200. Produces roughly 0.5, which means we're going to be reading through the table forwards, through the delay line, sorry, forwards, at half normal, well, half the sample rate, I guess you could say. And then, I mean, if you go at full, if you go forwards through the delay line at 1, then you're at a speed of 1. Then you're going to have nothing coming out because you're basically sitting, making the samples stay still. An octave higher, 1200, is going to make the delay read backwards through the delay line at a speed of 1. And you probably could figure out what that maths is all about. So I'm going to delete this stuff here because, like I said, I'm just going to scale my 0 to 127 values to 48, the octave below middle C, to 72, and that's good. That should work out. So I'm going to use this value here that I've got here as a kind of transposition ratio or a transposition factor. I'm going to use that along with the duration to basically read through this delay line at a certain speed, depending on what the pitch is. I'm going to need two things from my delay time. So I'm going to use a trigger there. That's not a trigger, that's a toggle. So I'm going to use new object TII trigger int. And there's one of those did you know tutorials about using trigger, in case you already haven't figured that one out. The first place that, it's going to go to a line, because like I said, that's what I'm going to use to drive the position in my delay line. And the first place it can go is just straight in there, so that we're setting the current. Every time we get a grain, we're setting the current delay time on that line tilde directly. And then we're going to want to go to some value over some amount of time to create our pitch change that we want. So let's first of all, we're going to use the duration, like I said. I'm going to make a new object, not multiply tilde, but I'm going to multiply with a float just to keep it all accurate. I'm going to take my duration and multiply it by this value here. And then I'll take the duration and also go to the end of the duration over that. Actually, first I'm going to need to take into account that I've started here, so I need to add the start point to this place that I'm going to end up going to create the pitch change. So plus 0 will keep it all floating point. So that plus that is where I want to go, and I'm going to want to go to it over the duration of the grain. So we'll need to make a new pack here with the floating point arguments, pack 0, 0 with floats. And we're going to, what did I say? Yeah, we're going to go to this value, which is the, try and neaten this thing up is probably going to fail, but I'm going to go to this, to the time that I've figured out is going to make my pitch change work. I'm going to do that over the duration of the grain. Okay, so that can go into the line tilde like that. I think that is finished. This should be our granular patch, and so I can save this in somewhere. Save it as, I like to call these abs because they're abstractions, and so I can easily tell. And I'll just call it abs delay. So now we're going to be able to build our delay poly out here, poly tilde. So let's make a new poly tilde, abs delay, and we'll make 16, since that's how many voices we just created of polyphony in our poly tilde, and I can hook that message up to that, and then we can take an easy DAC. Let's grab ourselves an easy DAC, oh yeah, and stick that in there. Something didn't quite work out right here. So if I save, I didn't save this, so it didn't actually load that poly tilde. So let me save this in here so we know it knows where its path is, and I'll call it Granular Delay, or something like that. So Granular Delay, and then I can bring up this poly tilde that failed to load before. And we saw it loaded now because I've got these outlets. Yay. So I'll hook up those outlets, turn this thing on and give it some values, delay, amplitude, durations, pitch. Remembering that these are probability tables, so you're going to get values of the Y oh no, sorry, values on the x-axis based on the probability, which is sort of the relative value on the y-axis. And I've got absolutely nothing coming out of this thing right now. Do I have something going in my delay time? There it goes. Okay, just as a, so that works. So just as a quick demo as to how you could fix this thing or make it even slightly better, if I put a cycle in here, you'll be able to tell that there's a little bit of clicking going on. Whether or not we can get rid of all of that clicking is another question. Okay, so there's a little bit of clicking going on. One thing that might help fix that clicking is if we there's probably a timing discrepancies between what the poly object is basically stealing voices that are still in action over here. We can fool the poly into thinking that the notes are actually longer than they are, so we can add like 10 to the duration that goes into the make note so that we're not as likely to steal voices. That might help. Let's see. It seems to be pretty clean. Obviously the durations, there's some things you could change here, like you're not going to want 0 duration. But otherwise, that's kind of ready to rock, I think. I hope you enjoyed that little patch a day, and I'll check you in patch a day 39. Cheers.